Good morning, everyone. I want to thank you all for coming to this morning's presentation. My name is Brad Dispensa. I'm a Principal Security Specialist for Amazon Web Services Public Sector. And today, this morning, what I want to talk to you about is some actual methods and techniques that you can use to safeguard, design, and leverage AWS tools to better understand how to secure your cloud, how to use some of the fundamental primitives that we have for AWS. So the first part that I want to cover is that there are a number of different services that AWS offers on the platform, and it gets more and more every single day. What we're going to cover today throughout this session is primitives that can be used across all of the different AWS services. So while we won't cover every single service on the platform, the techniques and methods that we're going to be showcasing this morning, you're going to see how we can use those in a reusable format across many different services on the AWS platform. And the same will be true when we touch some of the fundamentals of how we control the network access for our environment as well. Also, before I start, I want to give a thanks internally to another Amazonian who really created this entire presentation, Becky Weiss, who is a senior principal in the Identity and Access Management team. So thank you to Becky for this great content. So to kick things off, what we want to talk about is there's, again, a number of different AWS resources that we're going to be going through. Today, our focus is really trying to understand what each one of these core functions is and how we can leverage them. For that, again, there's two components that we're going to touch on today. The first is identity and access management for permissions, and this is really about how we control what we call a principal can do on the AWS platform. The second is that we're going to be looking at VPC level controls. So this is going to be the area of network controls and how we control ingress and egress for our network. So the first question that you should be asking is, in order to be able to secure your things, you have to know where your things are. So I can't tell you how to secure your environment if you don't know what your environment looks like. So to put this into an analogy, let's say that we have this house. The house looks a little bit funny, doesn't it? So there's no points of entry, the doors are sort of missing, so I can't really tell you how to secure this because I don't know how this environment is configured. But if we add some points of entry, now this starts to look a little bit better. Now I can start to say, okay, so these are the points of entry. These are where things are going to come in and out of this environment. So I can tell you that this is a door. The door opens. This is where we're going to make a change to this environment that can allow access to this house, as an analogy. So at AWS, as you likely have heard by now, we operate a global infrastructure. So when we create our resources, the first thing that you're going to be doing is going to be using an AWS account. And that AWS account contains data that belongs only to you. So you as the customer have the choice for which region, which area that you want to put your content. So within that account, again, we have that region space that we're going to be putting our content into. And then within those regions, you can move that content to any of AWS's global network. Today, we have 21 available regions for you to use. So all of the primitives that we're going to be talking about today can be applied to those different regions and allow you to control access to how those regions work. So the next portion is that within the regions, we have a method for subdividing those. And the way that we subdivide them is through what we call an availability zone. An availability zone, basically, you can think of as one or more discrete facilities within a region. And that's where we can put our workloads across multiple availability zones so that from a availability and business continuity perspective, we can have a durable, highly available deployment because the application is spread across a wide geographic area within that region. So within these regions, we also can create a networking construct. And that networking construct spans across all of those availability zones. And what we refer to this as your VPC, or virtual private cloud. So here again, this is something that you control. So you have chosen to make a private CIDR space. For folks that aren't familiar with that CIDR notation, this basically means that anything that's 10.0.something.something will be housed inside of this network. And within that configuration, what we can then do is add in subnets. And within those subnets, that's how we're going to allocate that large IP space that we've provided at the first portion. So now we have subnets that are housed in these availability zones within this CIDR block. And again, all of this is under your control. You define how you want to place these resources. So after that, we can put things in there. So now we can start to put things in like EC2 instances. And these are the virtual machines in the cloud that AWS offers. So now we've placed EC2 instances in the cloud. The next thing that we can do is that we can logically and dynamically control access to those resources, as well as adding additional resources like things like our relational database service that allows you to run database engine services on AWS in a managed format. So there's a lot of things that run inside of this VPC. So another example that we can put in there is if you're using an Active Directory controller. So if you're using, for instance, Managed AD, you can put those Active Directory environments in here. And so on and so on. So what you can see is that there's a lot of resources that we can put inside of the VPC. And that's just an example of some of the services. So there are some services that will operate and that you will control access to through this VPC construct. But there's also a separate set of services that are not inside of your VPC. And so an example here would be something like S3. So S3 is in your account. It's in your control, the data belongs to you, but notice that it's not inside of your VPC. That's because it's a service that AWS operates on your behalf. So AWS is responsible for the underlying infrastructure, patching, and maintenance of that service, S3, but you still have direct access to it within your AWS account. Another example of a service that would exist outside of your VPC is something like Amazon SQS. And then we can look at other services like DynamoDB, which again would have the ability for you to interact with them inside of your account, and in some cases, within that particular region in this case, but it does not live inside of your VPC. So there's a number of different services as well that have the same design pattern, but the idea is just from a sort of primitive foundational construct, it's important to understand that there are some things that will live inside the VPC, and there are some things that will live inside the region inside of your account. So how do I understand where that difference lies? How do I know whether or not something is inside of my VPC or if it's something that's inside of my account? If you're new to AWS, that might be a little bit confusing, and you might want to try and better understand, well, I have this service that I'm using now and AWS just offered, but I don't understand reading the documentation. Does this live in my VPC or does this live inside of the account? So I'll share with you a little trick that you can use in order to find that out. So in this case, you can just simply run a dig command. So in this case, I'm using dig to do a lookup on this RDS database. And you can see that the returned response is the private IP that belongs to the VPC, in this case, the VPC that's in that 10.0 range. So we can tell that this is something that lives inside of the VPC. Likewise, if we were to do the same thing with Amazon SQS, notice that this does not live within that VPC IP space. So this is a good example of something that would tell you this is a service that is operating outside of your VPC and something that's operating just at the region level inside of your account. And again, these are outside of your account, but it's really important to really stress everything that's in this picture is fully under your control. So even though it's not inside of your VPC, that doesn't mean that you lose control to it. And what we're going to look at when we look at some of these services individually is the methods and techniques that we can use from both a networking layer as well as an IAM policy layer that will allow you to restrict access to those resources. So in order to do that, we need to understand what are the methods that we're going to be using to secure those resources. So everything in AWS that we use starts with identity and access management first, because everything that happens on the AWS platform is actually going to be an API call. And whether or not you're using our AWS Software Development Kit, SDK, or you're using our console environment or the CLI, All of those are going to rely on access that you will provide via the identity and access management platform. And it's through that we're going to be using that service to control that fine-grained access to things that are inside of that network. And even if it's outside of that network, we're going to still use IAM to control our capability of interacting with that. So first, let's talk about the first component of that, which is the identity and access management part. So for identity and access management, or what we call IAM, basically what this is that the authentication and authorization, I stands for the authentication, and the AM stands for the authorization. It applies everywhere in AWS. So let's start from the first portion, which is the authentication portion. In this case, the authentication, or the I, is for humans. So I'm looking across the crowd, and I have yet to see an Android or a Kiva robot roll through, so I think it's safe to assume that everybody in this room is human at this point. Is that a fair guess? Okay, good. So for this is where we're first going to be provisioning resources to humans. So this happens through a couple different ways. We can use IAM to provide access to these resources based on long-term credentials that are provided in IAM, or short-term credentials. So if you've ever used AWS before, this should look familiar. This is an example of using IAM to pass credential information, in this case the console login, to allow you to access that particular user and get that user's privileges. So in that case, you're using this console-based login to leverage the permissions of that particular user. The other side of that is that there is an identity for things that are not people, for things that maybe a developer has access to or other resources in your account. So this would be sort of the robots analogy. So those things need access to. And a unique capability of AWS is that we don't require that developers have to put long-lived credentials into their code. Instead, they can use a really unique feature of AWS, which is role-based access. So role-based access allows you to control access to a given resource, in this case an IAM role, to tell it that it can do something on that resource's behalf. So if we look at this role being attached to an EC2 instance, this role allows you to deliver temporary credentials for that EC2 instance to be able to perform a specific operation, an API call with that particular permission set. So the reason that that's nice is, again, that the developer doesn't have to bake in that username and password that we saw on the previous screen. Instead, they can use this role-based access to get access to an underlying service. And what it's doing in the background is it's using those short-lived temporary credentials in order to make a call to a service like Amazon DynamoDB on the EC2 instance's behalf. Another really cool capability there is that as part of using that role-based STS access, behind the scenes, Amazon is rotating those credentials on your behalf. So you don't have to worry about long-lived credentials because the credentials have a finite lifetime. And as part of that role-based access, we're constantly making changes in the background that allows that role to expire the tokens that were being used. So this is true for other services as well. You can use this same role-based model for things like AWS Lambda to allow that Lambda function to have that permission or that capability of interoperating with other APIs, or things like, again, a role to be able to use application autoscaling in a service like DynamoDB, or to provide dynamic access to a service based on an event that maybe happens inside of your account. So there is one other scenario that we're not going to go as deep into, but we want to give you just a little bit of a sense of something to look for if you're a larger enterprise customer. So in this environment, we can also use this through something called identity federation. So we're not going to go too deep into identity federation for this talk today, but if you want to do a little bit of research on your own, the keyword to look up would be federation for AWS. And in this example, what you can see is that we're using a corporate identity solution. So this could be something like your Active Directory environment, whatever your IDP is, so long as it has the capability of supporting a SAML-based request. We can use that to authenticate you through your own infrastructure, but then allow that resource through that responding request to use a role on their behalf. So the nice part there is that it's a single username and password that your users already know and are already probably familiar with. And what that federation allows them to do is then assume a role based on that federation. So this is something that we see very commonly for larger enterprise customers or customers that are using AWS in a large multi-account configuration. There are also IAM roles. So what's really important to note here is that for the IAM principle, roles are really used for automated processes. They're used for AWS services, or they're used for federated identities. So they can, again, have these short-lived credentials. And IAM users are for direct human access. So there are some customers that don't even create IAM users in their account because they use federation. Or if they do create IAM users, the IAM users are used for sort of emergency situations where perhaps an issue has happened with their directory service and they need to get access to that account. So users are for humans. Roles are for processes or things. So let's sort of take a deeper dive on that so that everybody feels comfortable with how this is actually working. So in this example, let's say that we've got a role authenticating to a service like DynamoDB via the AWS CLI. So I want to, again, just give you a tiny bit more detail under the hood on how this actually happens. So if we were to actually look at the role-based call to the DynamoDB engine, what would it look like? So this isn't something you need to know. We're just providing this to you as sort of an example so that you can better understand what's happening behind the scenes. So this big block of text here is an HTTP post that we have that has information about that role that's being used. And if we were to take this apart, what you would see is the first portion here is the credential. This is the access key that the role is using in order to provide the capability for this principal to interact with the DynamoDB service. So here you can see that credential ID idea in the post. But we also have this other part, which is the signature. This is an HMAC-generated signature. And what it's doing is it's using the user's private key on the client device. And the nice portion is that HMAC signature basically is something that is unique to the entire request. So it's not something that is replayable. So the HMAC signature would be generated on the fly on the client every time that the client makes a new request. And so that's basically how the role is basically passing that information in the background to the DynamoDB service. So again, not important that you actually have to know that, but for some customers, it's helpful to sort of see that visually. So the other portion is, we talked about the identity portion of it, but now what about the policy portion of it? So on the identity and access management side for this principle, we have policies that can be associated with this principle as well. So every AWS service supports authorization via IAM policy. And what that allows you to do is, again, control fine-grained access to what that principal can do with the policies that are applied to it. The other thing is that the policy can be attached to a role or to a user or even to groups as well. So it allows you to have roles that can be used with policies in a repeatable fashion. So I can use the same policy across multiple different principals inside of the account. And then later on, we're going to talk about other places that this IAM policy can be attached, but we'll save that one for a little bit later. So again, this is something that's going to be used in the overall process for the authorization decision of whether or not a user, or in this case a role, can perform a particular operation. So every authenticated call that you make to AWS goes through authorization. And in this case, once the identity has been established, the policies that are attached to it make that determination of whether or not the resource is authorized to make that call, or to better understand who's asking. If the IAM policy on your principal says it can't do something, you can't do it. So an explicit deny is always going to trump an explicit allow, and that's because we want to make sure that customers have that capability of saying something explicitly is not allowed and not allowing it to be trumped by an allow statement. So again, if it says you can't do it, you can't do it. And the policy has to be crafted so that specifically it allows that specific resource to be authorized to make that call. So in this case, the principal has access to DynamoDB, but the policy also needs to be configured so that the principal can interact with a specific DynamoDB. So to make this process easier for customers, AWS offers a set of curated managed policies that are available to all customers. And you can see this in your console today if you go into the policy console within IAM and look at the orange boxes. These indicate managed policies. So these are things that we see as common tasks for customers on the AWS platform. So things like, I want to provide EC2 read-only access or S3 read-only access. And the nice part is that you can go into each one of these and actually see what the policy is, see what it does, so that you fully understand what these managed policies are allowing a principal to actually do. So let's go in and actually read an IAM policy. So this is a pretty simple policy. This basically has a few components that we're going to step through. The first part is the effect. The effect basically says whether or not the principal is allowed or denied to do something. So in this case, this is an allow statement. The principal is allowed. And the next portion is the action. What is the thing that the principal can do? And in this case, the action is DynamoDB star. So this says that we are allowed to do DynamoDB everything. So we can allow full access to everything within the DynamoDB API space. And the next portion is the resource. What are the things within that DynamoDB that we can interact with? And so in this case, the resource is everything. Every DynamoDB table, everything that's inside of our account that this principal has access to, this policy would allow. So in plain language, this basically allows the principal to take all DynamoDB actions. But because I suspect many of you in this audience are security-minded, you know that this is probably not a desirable state. We always want to try and design so that we are using least permission and least privilege where we can. So in this design, what could we do to better restrict this? So one thing that we can try and do is scope it down so that in this case, we're changing that action from a star to specific verbs. So now we're saying that there are a specific subset of DynamoDB calls that we want to allow. So in this case, the batch get item, and query capability, and allows this to basically take only a few specific DynamoDB calls. The other thing that we can do as a change is that we can modify the resource condition. So in this case, rather than saying that this policy allows access to all DynamoDB resources, we can constrain it to a specific set of DynamoDB resources. So in sort of plain language, this allows the DynamoDB action to take these specific verbs, batch, get item, and query, for these specific tables and indexes within DynamoDB. So as you can see, this allows us much more fine-grained access rather than just allowing that wildcard star access to the environment. Another thing that maybe is a little bit confusing is that, well, what is that block of text? What is that resource thing? So we refer to these as ARNs, or Amazon Resource Names. And if we were to sort of dive into that Amazon resource name format, what's really important to understand is that basically what the ARN defines are these things. It's the service, the region, the account ID that's going to be leveraged, and then any service-specific name. So in this case for DynamoDB, it would be this specific table and even a specific table name for this resource. So we can again use this to write even more granular IAM policies with another feature, which is called a conditional. So this was a newer feature that was offered earlier in last year. In this case, this conditional that we're looking at on screen is unique because what we allow you to do is specify a requested region. So for a lot of our customers in the public sector space, what we hear is that there are regional constraint requirements. We need to make sure that a principal can only use, say, DynamoDB if it's within the Canada region. And we want to make sure that they can't use a service that's maybe outside of the region, maybe in another country, or in somewhere where they just shouldn't have access. So in this case, we can modify this policy so that the principal only has authorization to use it if it's in a specific region. So this is a really powerful tool to allow you to have that fine-grained access to make a principal specific only to a specific geography. So there are also a number of ways that we can use this for things like other accounts inside of our environment. So when customers get large enough, they tend to not have just a single account. What we're about to see is that customers will develop a number of different accounts that have different capabilities. So it could be that you're using something like AWS Organizations, and what we want to do is have an environment that has a developer, maybe a pre-prod environment, or a separate enclave. But what we want them to do is still have access to some of those resources, but they're in different accounts now. So how would we allow that principal that lives in one account to access something that lives in, say, a different account? So let's look at the top portion here, where we have an IAM role that has EC2 instances associated with it. But I have a developer that has put code into S3, and we want that developer to be able to have permission to get to that S3 bucket that lives inside of another account. Well, how would we do that? So in this case, we can create a cross-account role, or a authorization to access a different resource in a different account. So in this case, I can authorize this principal to have the capability of interacting with other services, like in this case, S3. But how do we provide access to that S3 bucket? It's not a person, it's not a robot. So where is that access from the S3 perspective allowing that control? And the answer is that you can actually put policy on an S3 bucket as well. So what you see policy on S3 bucket is the S3 bucket policy, but the language is the same as what we were looking at a moment ago in the IAM policy. There's just a few little nuances that are different, and let's take a look at that. So this is an example of a resource-based policy on an S3 bucket. And you can see that the structure looks very similar to what we were looking at a moment ago. But in this case, now there's a new section here that I've highlighted, which is this principal. So in this case, what this is basically saying in plain language is, for this particular principal, we only want to allow this bucket to be accessed by this specific account ID and by a specific role. So if we think back to that diagram that we had a minute ago, the policy on the S3 bucket can allow that specific role from that developer that was attached to the EC2 instance to have access to this S3 bucket. And so what that allows you to do is also pass things like the resource on the bucket policy as well. So you can see that this resource is to a particular bucket, and also a particular key string path as well. So some bucket, some path. So we can get very, very granular with these bucket-based policies to very tightly control what a given principal has access to, both from the principal level, but as you can see, is also from the resource-based policy attached to the service like S3. So how does that actually sort of flow? So in order for this to work, both ends need to be authorized to make this call. So first, the EC2 IAM role needs to be able to call to S3, and then the secondary portion is that the resource-based policy, in this case S3, needs to allow authorization and access to that S3 bucket. So no matter what, this has to be an explicit allow on both parts. Otherwise, the default posture is deny, and the user wouldn't have access to that environment. So in this case, you can see, does the principal have access? And even with that cross-account configuration, they still would have access to this resource. So let's look at some examples of other cross-account access. This is, again, that same type of scenario, but in this case, we can use that EC2 role to call to another role that maybe has access to a different service, like DynamoDB. And it would follow the exact same design pattern of basically allowing you to assume a role across in another account that can then be used to call to, in this case, a service like DynamoDB. So now I'm leveraging a completely separate role in a completely separate account that can be used across accounts to allow me to have access to a specific resource that's authorized by that role that exists in another account. So if it's a little bit confusing to understand, well, how do I know what are the role capabilities, or how would I understand, which services support this or don't? There's a really helpful page that we have, which is an IAM reference page that lists basically for all AWS services what is actually allowed. So each service documents its own authorization features, and it often helps you with some basic policy language as well, so that you can use it as sort of a starting point so that you know what you need to look up, or what you need to be able to modify in your policy to allow it to actually perform something. So that first portion basically covers the IAM part of our environment. But what I want to step into next is, how would we secure the networking portion of our environment? So let's do a deeper dive on understanding how we can secure the VPC portion of our account. So if you remember earlier, this was our sample account environment. So we've got our resources. How do we control the flow of stuff that's going on inside of your network? So the first portion is that if we look at inside of the network, we have a number of controls that are provided by AWS. So the first one that we can provide secure connectivity is via something called a security group. And security groups allow you to authorize only the traffic that you expect to a resource like EC2. So this is a stateful packet filter that wraps around resources that exist inside of your VPC and inside of your subnet. And the default posture for a security group is always deny. So if it isn't explicitly allowed, a user wouldn't be allowed to use that from a network perspective. The other thing that's sort of counterintuitive from a security perspective, but is also a really strong capability for providing that secure access to the environment, is routing. So through routing, we can also very tightly control what access we allow to a resource, and more importantly, the ways that a resource can egress from that network, or how it will go outside of your network to someplace that may be expected or unexpected destinations. And then the final point is something that's called a VPC endpoint. And VPC endpoints are really unique and powerful because they provide you with a least privilege point of connectivity for a service. And it also allows us to do really unique things with policy on those VPC endpoints that we'll touch on in just a couple minutes here. So the first part I want to look at is the example of the security group. So let's dive in on that security group. So again, security groups are stateful packet filters that allow you to control the ingress and egress of traffic within a resource. So here you can see that we've got a pretty simple environment. We've got an application load balancer, some compute resources, and a backend database. So how would we apply security groups to those resources? So in this case, if you were to sort of logically think through the data flow, the first security group that I would want is that for this application load balancer listening on TLS connection, I would say we would authorize HTTPS port 443 for this security group. Then we can use a security group for the backend EC2 instances and say that basically what we want them to do is have access from that application load balancer, and then we can also segment so that the database service has the capability of listening to traffic that we expect to come from the EC2 instances. So if we were to sort of dive in and actually look at that connectivity, you can see here from an inbound rules perspective, this is pretty simple, right? We're allowing all public internet access on port 443, and that's what we would look for that first security group. But take a fine look at some of the details on this next one. Notice that this is just a little bit different. Notice that the source is not a CIDR block. Instead, a really powerful feature for security groups is that you can reference other security groups. So in this case, what you're seeing is that we are listening on port 8443, but the source has to be something that came from the application load balancer. So in this way, what we can do is basically, rather than having to hard code IP addresses inside of your security group, we can make references to other security groups that we expect the data to flow through. So in this case, I expect our web traffic is going to come through the load balancer and nowhere else. So that's how we'll control that access. And likewise, if we were to look at the security group for our database layer, I expect that the database will only be accessible via the compute layer and nowhere else. So we can modify that database security group to do the same thing, to have a reference to the upstream security group, which is the EC2 instances. So again, this is really helpful for developers because if you aren't familiar with that sort of networking connotation, this makes it really, really easy to visually look at the environment and then look at that data flow and assign it. So the area that we want to dive into on next is, again, routing, which a routing allows you to define the connectivity for the environment. So from an example of sort of a least privilege, what we can do within a VPC is every single VPC and subnet will have a routing policy associated with it. And that routing policy allows us to define least privilege for connectivity inside of that environment. So let's dive in on that. So in this case, I've got two subnets. And I also want to make sure that there's no communication for resources that exist, say, in this lower subnet to a public resource. So in this case, this resources in this subnet cannot send packets outside of VPC, and we're controlling that through the route table. So the route table will allow us to say that the only way that these can access the public internet is through something else, like a NAT gateway or a proxy host. So the route table entry for this environment would look like this, where you can see that the destination that's allowed is anything that's within the VPC IP CIDR range, but nowhere else. There's no egress for the internet gateway. But if we looked at the upper subnet, which sometimes you refer to us, or rather we refer to it as a public subnet. So public subnet is a little bit confusing because it's actually not a feature of a subnet to be public. The thing that makes a subnet public or not is that route table entry. So in this case, if we were to look at this route table entry, which is publicly accessible, it's because this EC2 instance has an ENI that has a public IP address. And then we also have things like the application load balancer with public connectivity. And that route table entry would be specifying that if we want to talk externally, we would use the internet gateway to communicate to the public internet with these resources. So resources that if we looked at this routing table, it allows us basically to look at everything that has internet-facing connectivity. And again, if we were to look at the route table entry, notice that this one is just a little bit different. You can see here that there's now a new destination, which is that 000 CIDR range. And that 000 CIDR range specifies the internet gateway, or IGW, that these resources would use in order to communicate with the public internet. And so that's what makes this a public subnet, is that that route table entry allows us to use that internet gateway to get outside of the internet. The other portion for this is that we can control access for that lower private subnet so that we can allow the upper subnet to transmit information out. In this case, maybe these EC2 instances want to be able to get out over the internet, but I don't want them public facing. I want them to be in that private IP. So how would I do that? So if you remember just a little bit ago, I mentioned that we could do something like a NAT gateway. So a NAT gateway exists in the public subnet, and what we can do is define a CIDR block inside of the private route table entry that would say, if you want to go out to the public internet, the way that you'll go out to the public internet is via this NAT gateway. And again, that NAT gateway would exist inside the public subnet, which has a route table entry that it would allow the data to flow out through the internet gateway. So resources in the subnet now can use that static route for egress through the route table entry, and again, using that NAT gateway. So that's how we would control access to a private subnet if we wanted it to still have access to the internet, but not be directly accessible via the internet. And again, if you wanted to see sort of what that would look like, here in the lower subnet, the route table entry now has that 000 CIDR range, but what you'll see is that that CIDR range points to this NAT gateway. From a least privilege perspective, AWS offers a variety of different routing options. There are so many different ways that you can control networking on AWS that we can't go through them all today, but there are a number of different techniques within AWS through things like Direct Connect, Transit Gateway, peering connections. All of these will allow you to control that fine-grained access either through policy or through these route table entries. So you only need to have the routes that you want in a particular subnet, and that's how we'll control access. Within the VPC, there's also something called a VPC Endpoint, and these allow really fine-grained least permission connectivity. So let's say that I've got these resources that exist inside of these VPC subnets. And what I want them to do is I want them to have access to an application that we're going to expose maybe in a completely different account. So VPC endpoints allow you to actually point those resources to that application that's being hosted into another account, as long as it's being fronted by a service like the network load balancer. And I can use that basically to point internal resources to that hosted application that it lives in a completely different account. How would I know whether or not this is something that lives inside of my VPC or something that lives in AWS hosted space? Again, we can use that dig trick. And here we can see that this is, again, pointing to IP space that is not in the public IP space. It's inside of the VPC. A really cool thing is that these VPC endpoints can also be used not when it's just 2 accounts, it can be used across multiple accounts. And it's also important to note that behind the scenes, AWS and through our traffic and knowledge of the network, all of these accounts have the exact same IP space. They all have the same CIDR block. And so even though these all have the exact same IP space, we can still route that traffic appropriately because we know through that VPC endpoint peering connection what the ultimate destination is actually meant to be. So we can also use this for private connectivity services to things like services like Amazon CloudWatch logs. So we can use this to basically say, we want these to have egress capabilities for storing logs in a service like CloudWatch. And again, the method I could use to figure out, well, is CloudWatch something that lives inside of my account, or is it something that lives inside the VPC? We can use dig, and we can see here that, again, this is a service that exists outside of my VPC, so I wouldn't have that first control, which is the security group. This is something that we're going to control through policy or through routing. But again, if I were to look at the dig command from the EC2 instance, again, we would see the same thing. It's pointing to external access. Creating a VPC endpoint is pretty easy. So in this case, what we're looking at is just sort of a snapshot of that in the console. So I would define what service I want to use. So in this case, I can select the CloudWatch log service, and from there we attach it to the VPC endpoint, and we can use that to allow these EC2 instances to communicate with that CloudWatch log service, which again exists outside of the VPC. But notice that there's no internet gateway on any of these subnets, or if you haven't seen that yet, that's sort of the neat trick here, is that there was no egress. There was no capability of communicating with that public IP. So we're using the VPC endpoint to allow these EC2 instances to talk to a service that lives outside of the VPC, but without having to expose them to the public internet. So in this case, when we constrain this so that there's no internet gateway, notice that when I use the dig command, it comes back as being within the VPC because we're using the VPC endpoint, which allows that private access inside the VPC. We can also use this for other services. So same thing, we can use it for services like S3 to control access to S3. So you can see here, we would attach that policy or that VPC endpoint to the route table and allow us to say that anything that's going to S3 is going to be leveraging this VPC endpoint. But there's a really neat capability here now. Within that VPC endpoint, we can also associate policy. So again, kind of taking it back to the very first portion of this talk, when I said that we can reuse these components over and over and over again, this is an example of basically using that construct where we created a policy that we could apply to principals or a resource-based policy to S3, but we can also use that same construct to make a resource policy now for VPC endpoints. So in this case, I can make a policy on this VPC endpoint that allows specific actions to take place with this endpoint. So again, just like before, this is the IAM policy syntax. But in this case, the policy that we're going to associate with the VPC endpoint is that we're going to constrain the egress to the service S3 to specific buckets. So in plain language, what this policy is saying is that access from this network can talk to S3 only from these specific buckets. And notice that there's also a condition here as well. This conditional string allows us to have a newly released capability within AWS policy, which allows you to specify a specific organizational principal ID. So if you're not familiar with AWS organizations yet, it's outside of the scope of this talk, but AWS organizations allows you to group sets of accounts together into sort of a tree-based topology. So what this policy is doing is actually pretty clever. What it's saying is that the VPC can only communicate with these S3 buckets, and it has to be something that's from a account that would exist inside of that organizational structure. So basically, we would only have access if the resource is inside of AWS organizations that we expect. So now we have an endpoint policy that's associated with this environment that allows us to control access, but we can also then apply another layer, which is policy again to the S3 bucket. And so if we look at the resource-based policy on S3, we can see that we can also apply that conditional logic to the S3 bucket policy. So here you can see that we've added a policy that says we're allowing everything inside of S3, but in this case, the source VPC has to be this VPC endpoint. So basically what this is saying is that it will only authorize actions when they came from this VPC endpoint. So this is a really powerful way to control access to the bucket, because now the bucket will only allow communication if it came from that particular VPC endpoint. So again, really, really powerful, and it allows you to do this for this type of configuration. And again, we can also apply that to the IAM policy as well. So we could apply this to a role on top of that. So now we have yet another fine-grained layer of access control via the role, which also we could specify in the policy syntax that all three of these have to use this particular role in order to access this environment. So you can control your VPC like, again, any other resource. So we could use it to provide authorization to how we move inside of the environment. There's a couple key areas that I didn't cover in this talk, but they're important for you to know all the same. There are services like the AWS Key Management Service that allow you to provide cryptographic capabilities within AWS. So if you wanted to let's say encrypt an EBS volume or encrypt objects inside of S3, we would be using the KMS service in order to do that. KMS supports policy syntax just like what we've been looking at so far for the other services. You'll see that the conditional statements are going to be a little bit different because they're based on the key policy, but that's something that we can use as well. We can also use AWS Certificate Manager, which AWS offers so that you can apply free SSL certificates to services like our application load balancer, API gateway, CloudFront, and again, we can control who has access to use that certificate management service via the policies that we just looked at. There's also visibility and detective controls, so things like CloudTrail that allow us to basically see who has made all these calls inside of our environment. So what I've shown you is all the different policies and the ways that we can interact with those policies. But from a security perspective, I also need to know, well, who has modified these policies, or who has made changes to them, or who has access to them. We can certainly address the question of who has made changes and who has interacted with them via CloudTrail, because all API calls that take place on the platform, be it the console, the SDK, or the CLI, will flow through CloudTrail, and we can actually see what a given principal has done in order to better understand or debug a problem. Likewise, if I want to see what's taking place inside of our network, we can use VPC flow logs to look at NetFlow-like data, and I can use that to help me debug if I was looking at the VPC networking layer and trying to understand, is traffic not routing correctly, or are we seeing traffic that's not moving in a way that we can expect? We can use that VPC flow log to help diagnose and better understand what's happening inside that VPC. And then there's a number of higher level security services as well. So GuardDuty and Inspector. GuardDuty is a threat intelligence service. So GuardDuty looks for you at the CloudTrail log data and also VPC flow log data, as well as DNS log data if you're using Amazon Managed DNS, to look for anomalies or threats inside of your environment. And it'll also report to you if a resource is behaving in an unexpected way. And Amazon Inspector is an agent-based solution that allows you to understand if a resource like EC2 has been misconfigured or has susceptibility to a known misconfiguration or vulnerability. So I hope this was helpful for everyone, and I hope this gives you a better understanding of how IAM principal conditions work and how you can apply VPC controls via VPC endpoints and routing and some of the other features. So I'll stick around if folks have additional questions, but otherwise, thank you very much, and I hope you guys have a great summit.